Hi guys, my name is Trevor Sullivan. I wanted to take a few moments today to talk to you about a service that I get really excited about called AWS Step Functions. Now, the AWS Step Function service is really powerful because it allows you to define an arbitrary set of tasks and execute those along a workflow. It allows you to define an input state and then run some tasks that actually modify that state and then provide a final output state. So it provides this little visual workflow that allows you to build things like parallel tasks, where you can have branches going in parallel. You can do timer-based services that wait for something to happen and then send a message. You can also do try-catch statements where you catch an error and you can provide different types of fallback behaviors depending on what the error is. And lots of different examples here. So there's another example too called job status poller, where you basically submit a job and you run that job asynchronously, and then you wait for a few seconds, you get the job status to see if it's finished or maybe if it failed, and then you check, and then if it hasn't finished yet, you just go on and keep waiting and getting the status until it actually completes. So I just wanted to show you at the very basic level how this service actually works. So there's two different ways that you can actually run code. So Step Functions itself doesn't run code for you, but there's two different ways to integrate services that actually do run your code, your business logic, with the AWS Step Function itself. So what we're going to do is create a really basic example here called Step Function Test. Let's actually call this combine names. So we're going to take a first name and a last name, and we're going to combine them together, joined by a space so that you get the full name. And what we're going to do is just provide a very basic service here called Hello World. We're going to start at a state called combine names, and you'll see how this works in just a second here. And then under the states property, this is where you actually give all of your states or your individual steps in the workflow a name and an action. So by default here, this little Hello World example will just pass through. So it doesn't actually do any work. It doesn't wait. It literally just kind of passes through. So what we're going to do is we're going to change this to what's called a task state. And then each task state has what's called a resource property. And the resource property is going to determine what gets invoked when we actually reach this state. So there's two different options that you have to integrate with step functions for task states. You have the ability to call an AWS Lambda function, and you can see I've got a bunch of AWS Lambda functions already defined in my AWS account here, or you can create what's called an activity task inside of the step function service. Now what's cool about the activity tasks, and we'll look at an example of both of these separately, is that the activity task can actually be implemented in any language that supports calling the AWS APIs. So for example, you could run your code out instead of in a Lambda function, you could run your code inside of, let's say, a PowerShell running inside of a container on a Windows operating system. You could run a PowerShell directly on an on-premises virtual machine that's running Windows Server or Linux or something like that. So, or you could even make a Python task, right? So you could run a Python container that uses the AWS SDK for Python to actually interact with the step function. So first, we're going to go ahead and just call an AWS Lambda function that combines a first name and a last name together. So let's go ahead and just call an AWS Lambda function called combine names. Now this Lambda function doesn't actually exist yet, but we'll go ahead and create it. So when we create a task state, we want to make sure that we specify the result path. So the result path is going to be our root state dot full name. So basically anything that we return from our Lambda function is going to get assigned to the full name property as our state object, under our state object. So then under our comment, we'll say this step function combines a first and last name together, joined by a space. So that way other people know what the purpose of this is. And if we graph this out really quick, you'll just see that it updates to show our actual state name. So what's going to happen is when we actually execute this step function, it's going to call the combine names. So it's going to come down to the combine names state, and that's going to be our entry point. It's going to execute this Lambda function. The result from this Lambda function is going to get assigned to a full name property, and our step function is going to end. So let's go ahead and just create this. Now, when you create a step function, it's going to ask you to choose an identity and access management role to execute under. Now, the first run experience will automatically create this states execution role for you, and that'll give it access to call the AWS Lambda service and call activities in the step function service. Again, we'll dive into those separately after we look at Lambda first, but just understand that this execution role is being assumed by the step function service, and that's what gives it access to actually call our Lambda function. So if you run into any weird errors where it's saying, something like access denied or unable to call your Lambda function or your activity task, just make sure that this IAM role that you've associated with it has permission to actually invoke those. So now we've created our state machine. So our state machine, again, here's our JSON code for it, and here's the graph of what it looks like, same as before. So now that we've defined this blueprint for our state machine, we can actually execute it. But what's going to happen is when we try to execute it, it's going to fail. So let's plug in some simple JSON here for our input state, like first name and last name, Sullivan. You can optionally enter an execution ID, but you don't have to. So the step function service is just automatically going to assign a GUID. And you'll notice what happens here is that it actually fails, right? So why did it fail? Well, if you scroll down in the AWS Management Console, you can actually see a step-by-step breakdown of exactly what occurred when you executed this state machine. So basically, we started the state machine, we specified our input state and the IAM role that we're using to execute it. Then we're entering our task state. So we're entering the first step of our step function. So that's going to call our AWS Lambda function. So you can see it scheduled the Lambda function here. So it reached out to the Lambda service and said, hey, I want you to run this combined names AWS Lambda function. But what happened? Well, it tried to start it and it just failed. And the failure code is 404 not found. So resource not found exception, right? And that's because we didn't actually create the Lambda function. So in order for this step function to succeed, we need to implement this Lambda function so that it knows how to take that input of first name and last name and then return a result. So let's go ahead and switch over to the Lambda service, and we're going to create a new function here. We're going to author this from scratch because it's very, very simple, and we're just going to call it combine names. Now, the runtime can be any runtime of your choosing. I just happen to prefer Python 3.6. And then you're also going to choose an IAM role for execution of the Lambda function. Now, because we're not accessing any other AWS services, we don't really need to worry about giving this role any special permissions. This Lambda role just simply needs to be able to execute and return a value. So it doesn't need any special permissions. When you create the Lambda function, it's going to ask you to set up triggers here under the designer. Now, we don't need to set up any triggers because we're calling this Lambda function directly from our step function separately, right? So we don't have to actually define a trigger like a CloudWatch event rule or like an S3 upload trigger or something like that. So we're going to close that designer and scroll down here to function code. Now, this function code editor is actually based on the Cloud9 IDE. And so that's why it looks the way it does here. So you can actually create multiple files and whatnot, but we're just going to use the default file handler here. So it's called lambda_function.py, and we have a function in there just called lambda_handler. So the event and context variables are automatically being passed in. The context provides some useful information about the execution environment of the Lambda function, whereas the event actually contains the event object that's being fed into the Lambda function when it's executed. So our AWS Step Function task state is actually going to feed our input state into this event variable. So all we need to do from this particular Lambda event handler is to basically return event first name, because we have a first name property in our state. Then we're going to add a space, and then we're going to add event last name. So this is literally all we have to put inside of our AWS Lambda function. So when we feed in the first name and last name variables as a JSON object, we're just going to return both of those combined together into a single string separated by a single space. So let's go ahead and just save our Lambda function here. Sure enough, it successfully saved. And now we're ready to go back to our step function and actually test things out. So here's our AWS step function called combine names. So we're going to just select that. As you can see, it errored out there. That's fine. So let's come into the state machine details and just double check everything. So sure enough, it's calling the combined names. The result path is still root.fullname. And so now we're going to do a new execution, and we're going to specify that same JSON input as before. So first name Trevor, last name, and let's just do something different like Jones. And we don't need to specify an execution ID, and it'll just automatically get assigned. And check out what happens. So in this case, our step function didn't fail, it actually succeeded. And that's what we expected to happen now that we've implemented the combined names AWS Lambda function, right? So now when we scroll down here to see our individual execution steps, we see the execution started, the overall step function execution itself. That happened at 0 milliseconds. At 33 milliseconds into the execution, our task state was entered. At that same time, the step function service scheduled this AWS Lambda function named combined names to execute, and it passed in the first name and last name state that we provided as input state to the overall execution of the step function. The Lambda function started about 100 milliseconds later after it was scheduled by step functions, and then it succeeded a couple hundred milliseconds later, about 250 milliseconds later, it succeeded, and it returned this output of Trevor space Jones as a single string. So it took that first name and last name and combined it together, and then finally the task state itself exited, meaning that the combined names task state is finished, and then because that's the last state in the process, it just ends the execution overall. So that's basically how you can implement an AWS step function using AWS Lambda. Now we're going to switch gears just a little bit, and we're going to do the same thing here. The only difference, though, is that we're going to, instead of calling AWS Lambda, we're actually going to use PowerShell as a worker process on my local machine here. So I'm actually on a desktop computer at home, and we're going to use PowerShell running on this computer to basically do the same processing that we just did with Lambda here, to combine the names together and feed that back into the step function service. And one more thing I just wanted to show you is that in the execution state, if we look at our output over here, so our input was first name Trevor, last name Jones. Our output state was we still have our first and last name properties separately, but we now have this third property called full name, which is Trevor space Jones. So this is the overall output object that was emitted after this execution finished successfully. So now what we're going to do is switch the contexts and go over to this task worker queue. So what you can do is, instead of calling Lambda, you can create this task queue called an activity task. You can give the activity task just any name. So we're going to call it combine names, or let's just call it combine my names. And we're going to call create activity. Now, when you create an activity, the only thing that really happens is you get this ARN, or Amazon resource name, that points to a new activity queue. So you can think of this queue, combine my names, as a task queue. And when a step function basically executes this task queue, what it's doing is it's putting a message onto that queue and says, hey, I have a piece of work that I need you to do, but nobody's actually going to pick it up until you explicitly tell it to go query this queue for work and then do something with the data that it was passed, or that input state that it's passed, and then it can send either a failure or a success message back to that activity. So we're going to take a look at how that works. So we're going to copy this ARN here. We're going to come back and we're going to actually copy this step function right here. And then we're going to go ahead and create a new one. So let's go ahead and create a new one. We're going to call combine names task instead. So combine names Lambda was our first one. Combine names task is going to be our second one. We're just going to paste that code in down here. And the only thing that we're going to change is the resource that we call, instead of calling combine names the Lambda function, we're going to call the step function service, or states service as it's shown here, we're going to call the activity task called combine my names that we just created. That's the only difference we're going to make. Everything else here stays the same, so our visual workflow is going to look exactly the same. We have a entry point of combine names. We have a single state in our step function workflow called combine names. It's a task type of state that calls an activity task, which is part of the step function's service. And then we're going to assign the result back to this full name property. and then we're going to end the execution. So let's go ahead and just create this state machine. We're going to use the same states execution role because we don't have any special permissions here in this particular case. And we're going to create a new execution. So let's go ahead and just feed in first name Billy and last name Sullivan. So our expected final state is that we're going to have a full name property get appended to this state called Billy space Sullivan. So let's go ahead and kick off this execution. Now you'll see something a little bit different happen here. So see how this little animation is showing, and this combined names state is set to in progress instead of success. So in our Lambda example, we immediately got failed at first, and then after we implemented the function, we got an immediate success because the step function actually executed the Lambda synchronously, it returned, and then it finished. But in this case, because our step function is calling a task and it's actually using it like a queue, basically what's happened here is we've started a new execution, it passed the state into this queue, and now it's basically just in a pending state until somebody comes along, picks up that task on the queue, and either sends a success or failure message depending on what happens inside of the program. So what we're going to do is switch gears a little bit here and run over to Visual Studio Code. So I've got PowerShell running here in Visual Studio Code. It's PowerShell version 5.1, which is the desktop or Windows version of PowerShell. PowerShell runs cross-platform now on Linux, Mac, and Windows, called PowerShell Core Edition. And you can also run that inside of a container. But in this case, I have my credentials all set up on my Windows machine, so I'm just going to use it from here. So let's start out by calling the get AWS commandlet name and check out what commands are available in the step function service. So there's a few different commands available here. We can get a list of activities. We can get a specific activity and look at the details of it. That really doesn't give you much information besides the actual creation date and time of that activity task queue. But then we can actually call the get sfn activity task command that gets a task off of our activity queue, and that's the one that we're going to call. So let's start out by actually calling get sfn activity list, and that's going to show us all of the activities that we have defined inside of our account. So we have this combine my names ARN. Let's go ahead and do Control-C to copy that, or Command-C if you're on Mac. And the next thing we're going to do is call the get sfn activity task command. So when we call get sfn activity task, we're going to specify the activity ARN. So this is basically, again, the queue name that we want to pull a task off of. And then you can also specify an optional parameter called worker name. So worker name is really useful if you have maybe a whole bunch of workers, maybe you've deployed your worker tier inside of a containerized process and you've scaled that up to have 10 or 20 or 30 containers running. You can actually specify an optional worker name. So in the case of PowerShell, you could actually use like the host.runspace.instance ID, for example. And that's going to give you a GUID, or a global unique identifier, that represents the unique thread that's executing this particular task. So again, worker name is optional, but this just helps you kind of trace things back in your log. So if you had an error occur, you could actually trace this particular execution or this task that was processed to a particular worker and then trace that back to a particular host in case that host died or something like that. So what we need to do is when we get this task off the queue, we need to make sure that we assign it to a variable. Now this is important because we're going to get back what's called a task token, and that task token is kind of a pre-generated password that allows us to complete the task with either success or failure. So I'm just going to hit the F8 key to run this one line and store this activity task inside this task variable. So let's go ahead and explore the task variable just a little bit. So I'm going to pipe it into the format list command. And as you can see, we've got a few properties on this task object that we got back from this queue. So we have the logged at date and time, which is basically when this task was added to the queue. We have the input state, which is basically the JSON that was passed in from the step function execution. Remember, we used Billy Sullivan as the first and last name. And then this task token property contains the kind of pre-generated token that we'll use to either send a success or failure message back to the step function's execution. So now, in order to either send a success or failure, we can use the send sfn task failure or task success command based on which one you want. If you have a long-running task, you can also send a heartbeat, and the heartbeat is basically just a notification to the step function service that your process or your worker process is still actively working on the task. And that's useful in case you have a timeout period. So, if it times out after not hearing back from your worker after like 30 seconds or something like that, you can send a heartbeat more frequently than that timeout period, and that's just going to keep that task active. But in this case, we didn't specify a timeout on our task. So what we're going to do is send a task success, and we need to specify the output. Now, our output here is actually this. We're going to use the JSON input. We're going to combine that together. So I'm actually going to take the task and .input and do convert from JSON. So this will be my full name, or let's do task object. So now task object contains a object that's been deserialized from JSON with a first and last name property. And so now I can do output equals task object dot first name plus space plus task object dot last name. There's nicer ways to do string manipulation in PowerShell, but I'm just doing this for ease of use for now. So we'll hit F8 to run that. And if we look at the output property here, we should now have Billy space Sullivan as a single string. And so now we're going to take that string and pass it. We actually have to put quotes around that. I almost forgot. So now let's put double quotes around it. Inspect that really quick with another F8. Okay, so now we've got the double quotes around it. And now we're going to specify the task token. So task.task token. So this is our command. Send sfn task success. We're going to use this pre-generated task token that'll bind it back to the execution ID that we started earlier. And we have our output, which is going to be this string, the single string that we generated here. So let's hit F8. And we're going to switch back over to our browser. And as you can see, before we even switched back to the browser, it had already finished here. So our input state was Billy Sullivan, and our output is still going to provide our input state, first name and last name, but we now have this third property called full name. And we actually processed that using a PowerShell process that was running on our Windows host. So obviously you would implement that as like a container or some kind of service worker process on a server somewhere. So as you can see, since we were talking for a while, our activity was scheduled at 33 milliseconds into the execution ID. And after we blabbed on for a few minutes, we finally started and succeeded that task worker. And then we finally succeeded the entire execution, returning Billy Sullivan. So that's pretty much everything I wanted to go over in this particular video, just kind of showing you how Step Functions works. It allows you to define one or more tasks. There's a bunch of other different task types. You can do wait periods for a certain number of seconds. You can execute Lambda functions like we already looked at. You can do a choice state that allows you to make a choice and go in a looping process. So you can do lots of different things with step functions, but I just wanted to show you a really basic example of how to actually implement step functions. So I hope you enjoyed this video. Please leave a like or thumbs up or comment if you have any feedback on this video, and I'll see you guys in the next video. Thanks for watching.